Okay, this is question number 12 from the book Pathfinder, chapter Newton's Laws of Motion, MCQ. Consider three identical massless springs. The left ends of the first, second, and third springs are affixed to a wall, to a block of mass m placed on a horizontal floor, which is not frictionless, and to a block of mass m placed on a horizontal frictionless floor, respectively, as shown in the figures. The right end of each spring is pulled by a gradually increasing force. When magnitude of the force becomes F, extensions in these springs become x1, x2, and x3 respectively, which is the following statement is correct. Now, this is the first situation in which I have separated the spring mentally, and this is the support. Since the spring is massless spring, so on a massless object we cannot have a net force, because then it will violate F is equal to ma principle. So this spring will have to have net force equal to 0 on it, because its mass is 0. Since F is acting on one of its ends, the same force in opposite direction must act on the opposite end, and the action reaction of this force will be on the support, and this spring will stretch and come to rest eventually. Now the second situation is the same situation, except that there is a block placed on a rough surface. Again, draw the FBDs of these two parts. A spring again is massless, so force on it will be 0, as explained earlier, and the action reaction force of this will act unblock. And similarly, we'll have the condition for third case. What's the difference among these three cases? See, the force on a spring is same in all the three cases. The difference is only in the accelerations produced by this F of the block connected to it. So suppose acceleration of this block is A1 and that of this block is A2. Why these accelerations will be different? In first of these two cases, there is friction, while in the last case, there is no friction. So therefore, net force acting on the block will be different, and therefore it will produce different accelerations. And the springs connected to the block in these two cases will have same acceleration finally. If A1 is the acceleration of this block, so will be the acceleration of this spring as well. And similarly, the spring in last case will be accelerated finally with an acceleration A2. But these accelerations will not affect our argument that the force acting on a spring should be 0, because F resultant is ma, Newton's second law. And even if there is acceleration and different accelerations in these two cases, even then this ma becomes 0 because mass is 0. So in all of these cases, F resultant is 0. In first case, mass is 0 as well as acceleration is 0. While in other two cases, mass is 0, there may be some accelerations. There are accelerations equal to accelerations of blocks in each case. And but still it will not make any difference, because ma is 0. The product of m into a is 0. So F resultant is 0 in all the three cases. And so in all the three cases, spring is stretched by the same force, and this force is related to the elongation. And since same force is acting on each of these three cases, the elongation produced will also be same. So option A is correct, that x1 and x2 and x3 will be same. What will be different in these three cases? Obviously, the acceleration of blocks will be different, but that will not affect the elongations in springs, because spring is experiencing the same force in each case.